and this is about data collection and data processing. There will be also slightly more about my lightning talk tomorrow at 4:30. So to get things rolling, the motivation is the following: that there is a huge data set edited by all people around the globe, which is the map, and the map is normally a multi-layered XML file. It's used for many things, and of course, it can export all the data for visualization. So as you can see, this area around our conference. But there is actually also plenty of data about something that's in spatial data. It's called points of interest. All places, all cafes, restaurants, trees, parking spaces, everything of any interest is described in this data, and this could actually be processed as flat data. So this is tutorial about this is a package work in progress, a package named OSMToolset. This is not yet registered. This will be registered very soon. So let's see. But it's already working. So what am I doing here? I'm loading here the map. So this is another package I'm maintaining, OpenStreetMapX. I will tell some more about it tomorrow, but this is also for processing routes and the map, and can be used for maps visualization. So I will just talk about making data frames out of maps. So the idea is the following: there's plenty pieces of information, and some of them are more usable than the others. And there are the pieces of information about various types of points of interest. So there's a great classification. It can be found in the documentation of the OpenStreetMap format. But basically, anything is described. The data is divided into classes. Then it's divided by subclasses. Like you have education and kindergarten, education and say university, education and library. So around this framework, there's a configuration file about what you want to extract from map, because there's plenty information of map. So I've identified some initial list, but this is a configurable. So this is an input data frame. This one does a built-in attractiveness path. The built-in file into the library, and basically also for aggregation and for other analytics, I added something like the points of attractiveness and range, because university is, for example, very attractive, but its range of influence, like saying I live close to the university. If you live 10 kilometers from MIT, you still live close to the university. But if you have 5 kilometers to kindergarten, it's very far to the kindergarten, okay? You all agree. So one thing is the strength of influence, and the other is the range of influence, and this can be used for various types of visualization. So basically, this is the configuration of the parser. So here I'm telling the parser what data points I want to extract from the map. So I have data on the map, and this is the configuration, and you can put whatever you want. And also on the way of keys, you can also just put asterisks that from some class of entity you want just anything. So this is configuration, what we want to extract. So we end up in a data frame, in a data set that is usable. Then we have file. So I have extracted. Extracted file from Boston area, for the central Boston area. So basically, if I click here and I select export, you can export or you can download huge files. Now, the problem with OSM files is they are totally huge. If you ever downloaded those map files, they are several gigabytes. And the problem with parsers is that parsers are slow. Okay, so now you can imagine what is the problem. So this is the motivation about using Julia. So I just ran it before the class. It was let's see what speed I get this time. It's kind of fluctuating on my laptop. Yeah, it was 40 megabytes per second. Now it's 12. But anyway, I have this parser when running tests and laptop had full battery connected to power. I can do something like 2 gigabytes of OSM file per minute. So basically, if you take entire country or if you take entire state, in a few minutes you can just extract each school, each restaurant, each place, location for further visualization. So this is as usable and as fast that the intention is to build a data frame of the entire Earth, and it's quite possible and easy. Okay, so that's it. And what we are getting a data frame about all those information. So for each location we have the class, we have this strength range and all the information. Of course, there are much more. So we could have names of a restaurants, type of food, and so on. But basically for many types of analysis, this is the information. This is the information to be extracted. And now there is the second thing. Since I have the strength of influence and range of influence, there is something like I can beat something like attractiveness index. So if I, for example, calculate it at the center point strata, center campus, I'm getting some values. Okay, what I can do, I have very few time, so what I can do it. First of all, so these are the points in this area that I've just calculated, so they are all around here. So here are around the campus, and you can, hover. So these are all the points. Of course, I can plot it. This notebook is available for a download on my GitHub account, and I pinned the report, so it's easy to find. Okay, so you can take this all process and extract this data and visualize it. But then the second thing, you can visualize it. So this is maintained by me Julia library that can plot the map. So I made an overlay plot. And then what you can do, since I have attractiveness ranges, I might, for example, ask which places have great walkability towards the restaurant, okay? And then I can do maps, and I could do maps and visualizations like this one. So you can have a restaurant intensity in each point of the city. So for example, you can see, of course, in Boston, we have much more restaurants in downtown than in the campus area. Or similarly, we could make, for example, a visualization about, say, its parking. Okay, yeah. Some people, I understand, some people are driving cars in Boston, so you are laughing. Yeah, so then you have intensity of parking, and of course this is an issue how we are going to aggregate single parking places. What do you mean? But basically this is built around something what is called walkability index, so you can build this type of data analysis. So the idea is the following: that we have maps, and the goal of the project is already be on Shift to get the very fast parser that actually is dumping the entire maps, whatever map you tag. You get a data frame dump, and then you can do it for any any analysis, any type of spatial analysis. And this is also combined with spatial indexing. So, for example, you can go through all this area, and you could see it visualizes very quickly. But even I've been experimenting with, like, you can take entire state, and it takes very short time to calculate attractiveness each point with very small granularity. Okay, so thank you very much for this presentation. This is all time I had, so thank you.